Hello friends, in this lecture I will explain about convolution theorem, which will be very helpful to solve you can solve most of the problems of inverse Laplace transformation, and you can solve certain integral equations, you can solve your initial value problems. So it is very important for these problems, and it is your convolution theorem. So before going to the convolution theorem, you should know about your convolution. Okay, you should know about your convolution. So what is convolution? Let's start. So from the definition, suppose we have to find the convolution of two functions, f of t and g of t. F of t and g of t. Suppose we have two functions, and then convolution of two functions is denoted by f star g. F star g means your convolution of f and g, and is defined by integral from 0 to t f tau g t minus tau d tau. That means we have to integrate with respect to tau, and limit will be 0 to t. Okay. So when we integrate, just note it, when we have to integrate with respect to tau, we have to consider, because this is a limit t, we have to consider t as constant. Suppose we have to integrate, because after putting the formula, we have to integrate with respect to tau, so consider t as constant at the time of integration. So for example, how to find convolution of two functions. Suppose we have we have to find 1 star 1. 1 star 1 means here f is 1, f is equal to 1, and g is also 1. Two functions we have to take. So f equal to 1, g equal to 1. Suppose, and we have to find this means convolution of 1 and 1. Okay. So according to the formula, what we will get? Integration from 0 to t, and in place of f of tau, so this is f of tau, so this is f of t equal to 1, g of t is also 1, so we have to write f of tau. Okay, f of tau means just replace t by tau. What to do? Replace t by tau, and here replace g of t means 1, and we have to write g t minus tau. In form of t minus tau we have to write. So since f of t equal to 1, so this is a constant, so if I change the variable t to the tau, then there will be no change in the function 1. So if f of t equal to 1, then f of tau is also 1, because there is no t. If there will be some t, then we have to replace it by tau. So therefore it is only 1. Similarly, g of t is also 1. So if I replace t with t minus tau, then there will be no change. It will be unaltered. So it is also 1. So your f of tau is also 1. Gt minus tau is also 1. So 1 into 1, 1, and only d tau we have. Just integrate it, and integration is tau, and limit is 0 to t. So after upper limit minus lower limit, so t in place of means this is the limit of tau only. So in place of tau put t. So this is t minus 0. So this is only t. So t is the answer. T is the answer. Okay. So your convolution of 1 and 1 is equal to t. Similarly, if you find t star 1, the your f of t is equal to t, and g of t is equal to 1. Is not it? So if f of t equal to t, what should I write? F of tau in form of tau. In place of tau, you can change the variable also. You can write x, you can write any variable other than t. So here I took tau. Therefore, we have to write in form of f tau. So f of t equal to t means f of tau will be what? Just replace t by tau. So in place of t, it is tau. Clear? Similarly, g of t equal to 1. G of t equal to 1. So g of t minus tau, if there will be some t here, then it will be replaced by t minus tau. So since it is only 1 and it's a constant, there will be no t. There is no t, so it will be remain unchanged. So it will be also 1. So f of tau equal to tau, gt minus tau is equal to 1. Therefore, this is what? Integration from 0 to t, and this is tau. F of tau means tau. Then gt minus tau is 1. So tau into 1 d tau. So tau into 1 means only tau. Just integrate with respect to tau. So this is tau square by 2. Limit is 0 to t. So upper limit it will be t square by 2 minus lower limit mane 0. Lower limit means putting 0 in place of tau, it will be 0. So for upper limit there will be some value. So it is only t square by 2. Clear? So convolution of t and 1 is equal to t square by 2. Okay. Now in the next example we took what? Two functions f of t equal to t and g of t equal to t. F of t equal to t, g of t equal to t. So therefore, what we have to write? F of tau gt minus tau. So if f of t equal to t, then f of tau will be tau. Just replace t by tau, so tau. Then g of t minus tau. G of t minus tau means we have to replace t by t minus tau. So since g of t equal to t, so gt minus tau will be t minus tau. Clear? We have to replace t by t minus tau because we have to write gt minus tau. So it is t, so we have to replace t by t minus tau. So in place of t, just I wrote t minus tau. Clear? So now put it in the formula. So it is 0 to t, tau, then t minus tau. Tau means f of tau, gt minus tau. So f of tau means tau, then gt minus tau is t minus tau. Clear? Just integrate it with respect to tau. So since we have to integrate with respect to tau, just consider t as constant. So just multiply here, tau into t and tau into tau, tau square. Clear? Now what it is? If you integrate it with respect to tau, consider t as constant. So t into integration of tau means tau square by 2 minus integration of tau square again. So it is tau cube by 3 and limit is 0 to t. Limit is 0 to t. So by putting the upper limit, it will be, this is the limit of what? These are the limits of tau only, not t. So tau. So in place of tau, we have to put upper limit and lower limit. So t into upper limit, this is t square by 2 minus, again in place of tau, it is t cube by 3. And for lower limit, it is 0, again 0. So for upper limit, there exists some value only. So t into t square by 2 minus t cube by 3. So it is t cube by 2 minus t cube by 3. So if you solve it, then it will be t cube by 6. Clear? So this is the convolution of t and t. So t star t is equal to t cube by 6, or you can read t star t or convolution of t and t is equal to t cube by 6. Clear? Now note that f star g is equal to g star f. That means it satisfies commutative law. Are they equal? So if I want to prove this, then you can prove like this, whether they are equal or not. F star g, convolution of f and g, by the definition we know that it is 0 to t, integration from 0 to t, f of tau gt minus tau d tau. Now suppose we put t minus tau is equal to x. So if t minus tau equal to x, then tau will be, if you take tau to right hand side, then tau will be t minus x, and d tau, this d tau we have to change the variable tau to x. So therefore we want to find dx and d tau. So tau equal to t minus x. So if you differentiate it, it will be d tau equal to minus dx, because we consider t as constant. So it is only minus dx. So d tau will be minus dx. Now go to the limit. If you what will be the limit of x, then because we want to replace tau by x, so therefore limit will be also changed. So therefore when tau equal to 0, because we are the limit of tau limit of tau. So when tau equal to 0, then what will be this? Because t minus tau we put x, so therefore when tau equal to 0, then x equal to t. Tau equal to 0, x equal to t. So x equal to t. Now when tau equal to t, then x will be what? Put it here. When tau equal to t, then it will be t minus t 0. So x equal to 0. This means x equal to means limit of x equal to t and x equal to 0 means this is the lower limit, this is the upper limit. So your integral, this integral will reduce to t to 0. T to 0 means your f star g will be reduced to t to 0. F in place of tau just put t minus x, so t minus x. G, t minus tau means your x, so f t minus x, g of x, and d tau will be replaced by minus dx, so it will be minus dx. So therefore it is suppose here it is minus, so therefore if you minus means if you want to replace means you remove this minus sign, then you have to change the upper limit and lower limit. If you change the upper limit to lower limit and lower limit to upper limit, then your negative sign, one negative sign will be multiplied because of the property of integration, we know that. So minus will be plus, so 0 to t g of x f of t minus x dx. I wrote first g then f because x is there and t minus x is there. So it is 0 to t g of x f t minus x dx. Now if you compare with the formula, then what we can write here? F tau gt minus tau, then it is f star g. Okay, so here it is gx, then ft minus x. So if you compare with this, easily you can write it is g star f. It is g star f means convolution of g and f. So what we got? F star g equal to g star f. So it satisfies the commutative law. So f star g means g star f also. Now second is f star 1 is not equal to f. Is it equal? No, because f star 1 means your, by definition it will be 0 to t. By definition it will be 0 to t, right? 0 to t, and f tau and gt minus tau means again 1 d tau, and this will be some integration of f from 0 to t, but here it is only f. So f star 1 is not equal to f, and here f star 0 is equal to 0 because your gt minus tau will be 0 here, is not it? Gt minus tau will be 0 here, so 0 into this will be 0. So f star g is always 0. So there are some properties of convolution. Now come to the convolution theorem. It is very, very important and it is very powerful also. So how? And first definition, and then we can apply this theorem to any problem. So what is the theorem? So if f of t and g of t satisfy existence theorem, because when we go to the some Laplace using Laplace transformation, then we have to first check whether they satisfy existence theorem, means their Laplace transform exists or not. If their Laplace transform will not exist, then we cannot apply to any theorem or any problem. Therefore, first we have to check whether this means when we operate any function, then that those Laplace transform exist or not, we have to first check. So ft and g of t satisfy existence theorem, and we know that what is existence theorem. What is the existence theorem? In the previous lecture I already defined, means that is your f of t and g of t must be piecewise continuous. Secondly, it must satisfy the growth restriction, that is mod of f of t less than equal to m into e to the power kt. Similarly, g of t also satisfy the mod of g of t less than equal to m into e to the power kt. So therefore, f of t, g of t, if satisfied this existence theorem, then we can apply this. Then we can go to the next step. So if Laplace, if existence theorem exists, then Laplace of f of t exists. So Laplace of, if suppose Laplace of f of t equal to f of s and Laplace of g of t equal to g of s. Suppose Laplace transform of f and g are f of s and g of s. Then what will be the theorem? Says that Laplace of f star g, Laplace of f star g, means Laplace of convolution of f and g will be fs into g of s, means their product, means Laplace of convolution of any two function is equal to product of their transforms. We can also say like that. Laplace of convolution of any two function is equal to product of their Laplace transforms. Okay, or if you take Laplace inverse on both sides, then what you will get? Laplace inverse of fs into gs is equal to f star g. F star g. Okay, so it is very powerful in the sense that you can apply in every problem, every type of inverse problems, or we can easily solve the problems. How? From the example here, Laplace, suppose you have to find Laplace inverse of 1 by s into s minus 3. 1 by s into s minus 3. Clear? So, Laplace inverse of just write this function in form of 1 by s into 1 by s minus 3. You can write like this: Laplace inverse of 1 by s into 1 by s minus 3. Now, if you compare with this theorem, then what it says? Laplace inverse of fs into g of s. So, if you compare this, then this is fs, this is gs. Okay. So, we have to remember that how to apply this theorem. Just note it, that break this, means write this given terms in the product of two functions. In the product of two functions whose Laplace transform exists. Clear? Whose Laplace transform exists. We have to check whether their Laplace transform exists or not. If Laplace transform exists and we know the formula for this, then you can easily find the Laplace inverse. So therefore, because we know that 1 by s means this is the Laplace of 1, and 1 by s minus 3, this is Laplace of e to the power 3t. So therefore, we write like this: this is fs, we consider this as f of s, and we consider this as g of s. So Laplace inverse fs into g of s. So fs into g of s. So f of s is 1 by s, g of s is 1 by s minus 3. So directly you can apply the formula by the theorem, the definition of the convolution theorem, that this value will be f star g. F means inverse of this, small g means inverse of this. Laplace, because what? Small f is inverse of capital F of s. Small g is inverse of capital G of s. So since we consider 1 by s and 1 by s minus 3, what we have to write? In place of small f, it will be inverse of 1 by s star inverse of 1 by s minus 3. So 1 by s, whose Laplace transform is this? Means whose Laplace transform is this? It is only 1. And whose Laplace transform is 1 by s minus 3? It is e to the power 3t. So result will be what? 1 star e to the power 3t. Convolution of 1 into, means convolution of 1 and e to the power 3t. So only we need to find convolution of this convolution, 1 star e to the power 3t. Clear? So, and as usual formula, we can apply this formula to find out the convolution of this, because take it as f, take it as g. So f of tau means e to the power 3 tau, and g of t means 1. So gt minus tau will be 1 again, because there is no t, so we have to not replace anything. So it will remain unchanged. So e to the power 3 tau means this is your what? F is e to the power 3t. G is 1. So f of tau, this is f of t. So f of tau we have to write, so e to the power 3 tau, e to the power 3 t. So we have to write e to the power 3 tau. And 1 means there will be no change. So e to the power 3 tau into 1 into d tau, and limit is 0 to t. So just integrate it. E to the power 3 tau by 3, limit is 0 to t. And if you upper limit minus lower limit, if you take, then the result will be this: 1 by 3 whole into e to the power 3t minus 1. Clear? So in this way, you can solve your inverse problem using convolution theorem. Right. In the next example, you can check here, we have to find Laplace inverse of 2 divided by s into s square plus 4. Right. So how to find this? Easily how to solve this, or in other way you can solve also using partial fraction, or using any type of arrangements, but using convolution theorem, easily how to solve. Just compare with this, because we have to find Laplace inverse. So just compare with this Laplace inverse fs into g of s. So how to adjust it? Just means we have to write what f of s, and we have to consider f of s and g of s, so that we know, means we can find Laplace inverse of f of s and Laplace inverse of g of s. So since here it is 2 divided by s into this, so just I wrote what 1 by s, because we know that Laplace of 1 is 1 by s, and 2 by s square plus 4. This is the Laplace of what? 2 means your sine to t. So therefore directly we can write Laplace inverse of fs. If you consider this as f of s, consider this as g of s, so the result will be what? F star g. The result will be f star g. So inverse of this and inverse of this. So inverse of 1 by s is 1. Inverse of this is sine to t. So the result will be what? 1 star sine to t. Don't write it 1 into sine to t. This is 1 star sine to t. Convolution of 1 and sine to t. Okay. Often students make mistake like this, that Laplace inverse of this into this means Laplace inverse of this and Laplace inverse of this. Is no. This is not, because this is convolution. This is not a multiplication. This is not into. This is convolution. Just note it. Seriously note it. This is 1 star sine to t. After inverse, just find its convolution. Otherwise, it will be wrong. So Laplace inverse of this into this will be what? 1 star sine to t. Convolution of 1 and sine to t. So we need to find its convolution now. So convolution is what? According to definition, it is 0 to t. F of tau, consider this as f. Okay, easily you can find, or you can take this as f also. You can take this as f also, because it is having commutative property. So if you take f sine to t and g is your 1, then f of tau, so it is sine 2 tau, because f of t is sine 2t, so f of tau is sine 2 tau. Then g of t is 1, so g of t minus tau is also 1 d tau. Just integrate it and find your answer. So integration of this is minus cos 2 tau, 2 tau by 2, limit is 0 to t, so upper limit will be, means 1 minus 1 by 2 take common, and it will be cos 2t minus 1, means cos 0. For lower limit it will be cos 0, upper limit it is cos 2t, for lower limit it will be cos 0 minus 1. So therefore the result will be what? If you take minus into the bracketed term, so 1 by 2 into 1 minus cos 2t. Clear? So this is the Laplace inverse of this. So easily you can solve so many problems, this type of problems, using convolution theorem. So it's a very, very important and most powerful theorem in whole Laplace transform topic. Clear? So in the next lecture again we will discuss some problems of based on this convolution theorem, how to solve, how can we solve this very critical problems easily by using convolution theorem. And again we will solve some integral equations, we will solve some initial value problem using this convolution theorem. Okay, in the next lecture again we will meet. Thank you all.